Chords in circles. Okay, so here we've got a diagram. We've got two chords, A, B and C, D, and they intersect inside the circle at point P. What we're looking to find is the connection between the two parts each chord is divided into. Now we're going to add some extra lines to the diagram to make the connection clearer. So now I've got two triangles, APD, this triangle here, and BPC, this triangle here. Now I can say that APD, this angle, and BPC, this angle, are equal because they are vertically opposite. ADP and CBP are equal because they are angles in the same segment. DAP and BCP are also angles in the same segment, so they are equal to each other. So I can say that triangle DAP is similar to triangle BCP using AAA. Because the triangles are similar, we know that corresponding sides are in the same ratio. So I can say that AP over DP is the same as CP, so CP corresponds to AP, and CP over BP. Now I can cross multiply there, so multiplied by BP multiplied by DP, get the relationship AP times BP equals CP times BP. So the product of the two parts of the chords are equal. Notice each edge has got P involved, so it's all the different letters and how far away they are from P. Let's have a look at an example. Here I've got two chords. I'm told what the separate parts are equal to. Using intersecting chords theorem, I can say that 3 times x is equal to 4 times 9. So that gives me x is 36 over 3, which is 12 centimetres. Here I've got the situation where the chords intersect outside the circle. So I've extended the chord onwards for both of these until they meet. Again, I've named my point P. Let's consider the relationship between the two parts of the chords, the part inside the circle and the part outside the circle. To put some extra lines into the diagram, which give me two triangles. I've got the triangle APD and BPC. Now, I can say that PAD is equal to PCB. They're angles in the same segment of the circle. I can say that angle APD equals angle CPB. It's a common angle. It's common to both triangles. So because these triangles have two angles that are equal, I know that the third angle must be equal. So I can say that triangle DAP is similar to triangle BCP using AAA. So because I know that corresponding sides are in the same ratio, I can say that AP over DP equals CP over BP, and as before, I can cross multiply to get this relationship. So you see that the relationship is the same regardless of where the chords intersect. The important thing is just to make sure, if let's say P, we always call the point of intersection P, and the P is included in each part of our two products. Let's have a go at intersecting chords theorem when the intersection is outside the circle. So I'm going to start by labelling. This means that I can make sure I get a P, a letter P, in every single part of my relationship. So A to P is x plus 4, B to P 4, CP all of this, so 3 plus 5, which is 8, and DP is 5. Evaluate the product on this side, write this slightly nicer. I can divide by 4 and then subtract 4. Okay, have a go at questions 1 to 3 now. Pause the video while you do that. Make sure you mark your work. Now, super important that you draw diagrams. None of these questions have diagrams, can get quite confusing. There's all kinds of letters flying around. So make sure you've got a diagram so you are less likely to make a mistake. Okay then, let's have a look at our last theorem here. So we're considering the triangles here, PAT and PTB. You can see here that PT is a tangent to the circle and PAB is a secant to the circle. Now I can say that ATP is equal to TBA using the alternate segment theorem that we looked at last lesson. I know that APT is equal to TPB because it's a common angle to both triangles. Because I know that two angles in these two triangles are equal, then I know that the third one must be. So I can say that triangle PAT is similar to triangle PTB using AAA. From this, knowing that corresponding sides are in the same ratio, we can say that PA over PT is equal to PT over PB. And then cross multiply to get PT squared equals PA times PB. So this length squared equals this times this. And that's our final theorem. Okay, if you could complete the remaining questions, pause the video while you do that, and I've got some solutions, some worked solutions for them after. Okay, if you have any questions, make sure you post them in the discussion. Thank you very much.